Hi, welcome back. In this interview with a renowned expert in water management, who is also a recipient of the prestigious Stockholm Water Prize this year, Prof Günter shares his key insights on the escalating challenges of flood risk adaptation in the context of climate change. The professor highlights the complex interplay of factors influencing flooding, including increased convective weather events, altered water cycles due to human activity, and varying flood patterns across small and large catchments. Emphasizing the need for a multifaceted approach to flood management, he advocates for localized strategies tailored to specific conditions. Integrating scientific research with practical applications in engineering is the heart of his work. Finally, he talks about the urgency for water to assume a more prominent place on political agendas. Have a listen. So without further ado, thank you, Prof, for taking your time to speak to us. I know it's 11 a.m. in Vienna. Really appreciate you accommodating to Singapore time for this interview. I would like to start with asking you a few questions. Firstly, congratulations on winning the Stockholm Water Prize. What does it mean to you actually winning this award this year?
Thank you so much for the congratulations. The Stockholm Water Prize means a lot to me for a number of reasons. So first, of course, it's nice that my own work is appreciated in this way. My work on floods, reducing flood risk, understanding flood processes in the context of climate change. But on the other hand, I think it's a token of esteem also for the discipline at large, and also for the importance of the topic of flood risk and flood risk mitigation.
I think I'm from Singapore, it's Southeast Asia, and floods is a very common thing right now. We recently experienced some floods, so I think your insight will definitely benefit us to know more about how to solve flooding, especially here due to climate change. So understand that your research has advanced the understanding of hydrological processes and water management in the context of climate change. So what do you see right now as the most pressing issues in the water sector facing climate, the water sector faces as climate change continues to intensify?
I think the most pressing issue is to adapt to the changing flood risk. And the important thing is that these changes are not the same everywhere. Usually people think, well, floods are increasing with climate change, and this is only half true. It is true in some catchments, but it's not true in other catchments. What we see very clearly on the basis of data in many places is that convective events, thunderstorms, they are increasing because of the increased availability of energy for the movement of water, in particular for the movement of water and for the movement of air in the atmosphere. As the air moves up more quickly in the atmosphere in a thunderstorm, then also the rainfall that can be produced increases, which increases the effect of these thunderstorms on flash floods. These are very short floods of a couple of minutes or hours, but are most relevant in small catchments. So for small catchments in many places around the world, we are seeing increases in the floods. When we look at the bigger streams, the situation is not necessarily the same. And this has to do with the mechanisms of rainfall generation and also with the mechanisms of runoff generation. Once the water drop hits the ground, what happens to the drop of water? And it's different in that we can see on the basis of measurements that in some regions in the world, the floods do not increase, they decrease. For example, because soils are drying out, because of the increased evaporation. As the soils are drier, more water can infiltrate and the flood risk decreases. Or in the regions where there is snow melt that contributes to floods, there is less snow in many parts of the world because it's warmer. Less snow means less snow melt. and less risk of snowmelt-induced floods. So the entire thing is complex, and in order to adapt to climate change in an efficient way, we need to see these differences. We need to understand what the processes are of changes of floods in different hydrological contexts and take this into account in the decision making.
I see. I'm just thinking about the basic water cycle that we learn in school. I think it has definitely gotten more complex over the years because of climate change.
The basic water cycle has become more complex for a number of reasons. One reason is climate change. The physics is still the same, because the physical laws, they still apply, but the fluxes, the movement of water changes. So what we see in many parts of the world is that evaporation is increasing because there's more energy. For example, in the country I'm coming from, in Europe, in Austria, we have observed that the evaporation has increased by 17% in the last 30 or 40 years, which means there's much more water that leaves the ground, goes back in the atmosphere, less water is available underground for the growth of plants, for agriculture, for the ecosystems. So these are changes we are seeing, still obeying the same physics. But there is another process that's equally important, is direct effect of humankind on the water cycle. So, for example, direct effects through the abstraction of water from the water courses or from groundwater for irrigation and other water supply purposes, changes of the water cycle through land use changes, urbanization, different methods in the agriculture, changes of the water cycle through hydraulic structures or changes in the river systems. So it is climate change that affects the water cycle, floods, and also water availability. But that's not the only effect. We also need to account the other more direct effects of humans. And then this is important in decision making, because if we attribute a change to climate change in reality, but it's a different process, then our adaptation works will not function. So we need to attribute to the right causes in order for adaptation measures to really work in the future.
I see. So, Prof, could you share some solutions that you have when it comes to flooding and water scarcity? I like the distinction that you said between climate change and, human action. So what do you think are the solutions? And for us, for Asia, how do you think we should adapt to these challenges?
Solutions to floods and flood risk are manifold. There are many. And there, on the one hand, there are solutions we call structural solutions, that is building infrastructure to protect cities, for example, against inundations, construction of levees. There's also a solution that's called mobile walls, so mobile levees that are aluminium walls that are erected just before the flood, particularly interesting in cities where there's little space. But then retention of water in reservoirs, particularly relevant for smaller streams and if there's space. So generally retaining water in the landscape, make infiltration of the water increase. This method does not work so well for the big floods because the relative infiltration is small. So for example, if you increase the forest cover, you plant trees. Usually people say, well, let's plant trees to reduce flood risk. Usually it doesn't work. It does reduce the small floods, but these are not the ones that really make the trouble. We are more interested in the big floods, 100-year floods, or even bigger floods. And for these floods, in most regions of the world, afforestation has no effect, almost no effect. Same with renaturalization of the streams, river restoration. And people say, let's increase the biodiversity of streams. And this is a very good thing. I could not agree more with that. To increase the biodiversity and the livelihood of the ecosystem is a very good thing. But in most cases, This has very little effect on the flooding. And this is important to recognize because society potentially may spend a lot of money on river restoration, which is still money well spent, and then expect that flood risk reduces, but it does not.
Yeah.
Because we can calculate by hydrological methods very accurately the effect of river restoration on the flood risk. And usually it's minute to non-existent. So we don't want to create false hopes for politics. We need to see very clearly what is possible, what is not possible. River restoration usually does not decrease the floods, but may still be good to do for many other reasons.
I see. I mean, I've spoken to a few experts and they did share about the nature-based solutions, about trying to find nature-based solutions to solve nature problems, right? But I think you did really highlight the distinction, whether it's really helping the floods or, you know, helping other things. So that distinction is quite important.
Yeah, my opinion on nature-based solutions, I think it's pertinent here in the discussion. I think it's a good thing, nature-based solutions for many reasons, to follow the ideas of nature, of addressing certain goals. But then on the other hand, nature-based solutions can only do so much. Sometimes their impact is overstated. So, for example, but then on the other hand, sometimes they work well. So it depends on the situation. So nature-based solution would be, for example, increase infiltration in urban centers. And that's a very good thing. So that's already done in some cities. The keyword is sponge city. It's a good thing. We increase infiltration, which reduces flooding, increases groundwater recharge and water availability in the groundwater for nature and for other uses. It's a good thing. But then for these kind of measures, the flash floods don't go away by magic. They are reduced maybe by 5%, 10%. There's still flash floods. There still will be inundation. So for this example of nature-based solutions, often nature-based solutions can be a contribution to flood mitigation. But only in rare cases that it can fully address the flood risk problem. So a prudent choice often is a combination of measures. And one aspect can be nature-based solutions. It's a good thing. Retention water on green roofs, for example. But then this reduces, depending on the setting, maybe the flood by 5%, 10%. The floods don't go away. They still can be very dangerous. And then also a mobile wall, for example, or retention basins. A combination, a portfolio of solutions very often is the right choice. And the mix needs to be adjusted to the local situation. It's not everywhere the same mix. In some places, maybe land use, urban planning is more important. People need to move out from the flood hazard zones. In other places, we can build a retention basin, we can build a flood wall, other structures. Sometimes evacuation measures are more appropriate, and often they are needed anyway. So it's a mix, and the mix depends on the local setting.
Thank you for explaining the nuances. I think there's really no one solution that fit all from all that you explained about the case study. So, Prof, I know you're in the Vienna University of Technology. I would like to know more about how do you think, especially you in the academic research and universities, how do you think the crossover can also help solve these complex water issues with the water sector?
Yeah. Thank you for the question. It's a question that's close to my heart because I'm both scientist and engineers. So I'm scientist who does fundamental research. Only last week came out a paper in Nature on increases of extreme rainfall and the impact on flooding in small and large catchments. That's one of my hats. But the other hat is also in engineering, and I play, for example, in Austria, a major role in the Committee of Large Dams. So being involved in decision-making of permissions for dams. That's my engineering hat. And I think this combination of fundamental research, increasing the knowledge on these flood processes on the one hand, but also the application of this knowledge for real-world practical cases and difficult decisions. So often these decisions are not obvious, not easy to make. Or planning of infrastructure and flood mitigation measures is not trivial in many cases. I think this combination of theory and practice is very important. Something it's really close to my heart, something I really like, that's really important to me.
Thank you for sharing your passion. I want to move on to the question about now focusing on the water prize that you just won. It is for individuals who have made contributions to solving the global water challenges. So as you're wearing two hats, right, how do you envision especially the role of international collaboration in addressing, flooding as well as the water issues, the interconnected water issues here?
Yes. As you're saying, water issues are interconnected. So the global cooperation and collaboration across boundaries of countries is very important. The first thing, of course, is exchange of knowledge, understanding of the processes, of understanding of the potential of various solutions. We can learn very much from other places. This is sometimes underestimated. This applies both to the science and to the actual solutions and experience with solutions. Sometimes people say every place is different in their water management problems, so we need tailor-made solutions and we need to reinvent the wheel in every place. It is true that every place is different, but we don't have to reinvent the wheel. We can learn from other places. And one vehicle for doing that is a new discipline that's called socio-hydrology. So this is a discipline, I'm the co-founder of that, and it's also important to me, is the recognition that humans are part of the hydrological cycle. And we should not treat humans as a boundary condition, but as an intrinsic part of the water cycle, including the feedbacks between human actions and the water cycle. For example, the effect of humans on increasing floods, for example, through the loss of floodplains, but then also the effect of the floods on human decisions, building a dam, for example, or regional planning. So this is the idea of sociohydrology, and the same applies to droughts, for example, water availability, and the same applies to water quality. The effect of humans on the water quality, contamination of groundwater, for example. But then what is the effect of the contaminated groundwater on the economics and human decision-making? That's the heart of sociohydrology. And now one of the strengths of this idea and this framework is that it helps learning from other places. And that's why I'm mentioning it here. So each city, each place with their particular water problems also follows some socio-hydrological patterns. Socio-hydrological patterns that can be explained by causality, by quantitative modeling, not just by stories, also stories, but not only stories. And this makes this information and this knowledge more transferable between places. So returning to your question, how important is international collaboration? Very, very important.
Thank you. I find the social hydrology so fascinating actually when you talk about the human patterns or human relationships in relation to flooding and nature. We always see it as a very external circumstance issue, but actually it's more interconnected that we point out with social hydrology. Thank you for sharing that. We're on to the last question already. So we want to know, looking ahead, what are your thoughts on the future of water governance and policy, and how this cross-collaboration with governance, industry, and the academia work together to create a more resilient water system in light of the increasing environmental pressures?
I think the future of water governance is that water in general should get a higher profile within society. If we look at decision-making at the government level, at the national, local level, then water often is one out of many issues. of course, social issues, economic issues, and so on. There's a long list of things governments deal with. And water is not always the top priority. Very often it's somewhere middling or further down. I think what we need in the future is to bring water higher up in the agenda. It should be towards the top, not towards the end of our political agenda. Why is that? Because water resources are becoming scarcer, so we need to be more careful in the decision-making. Water is a very valuable good. It is a special good. It is so important for the livelihood, and it needs care, and it has also the characteristics that it's difficult to transport. You cannot send it through the internet because it's bulky. It's bulky. It's precious, it needs to be protected, it needs to be cared for. So my main message is bring up water higher up in the political agenda.
Thank you for sharing, Prof. I think it's very interesting as well when you mentioned about the internet, right? And turns out water is needed for data centers and the semiconductor industry. It's water is just needed everywhere. And yeah, I think definitely putting it at the top of our priorities is the way to go. Thank you so much, Prof. Do you have anything else to add or share or mention that I might have potentially missed?
I would like to use this opportunity to thank all my collaborators and friends and family for the cooperation and friendship over the years, because this Water Prize is not only a recognition for myself, I also see it as a recognition for the environment in which I'm working and in which I'm living. So at this point, thank you so much to my friends, collaborators, and family.